Good morning, students. So today we are going to solve few selected sums from Ncert. So I have written few sums from Ncert. So you can find these sums in your book. Please open your book and match. So exercise 1.1. So it's very simple. They have asked you to write something in set builder form and roster form. Okay. So the first, they have given few elements like 2, 4, 8, 16, 32. So we can see that these are the powers of 2. Okay. So what we will write in set builder form, you know, in set builder form what we do, we write the set in terms of language, mathematical languages. So these are what powers of 2 starting from 2 to the power 1 up to 2 to the power 5. 2, 1, 2 to the power 1, then 2 square, 2 cube, like that. So what we write over here, 2 to the power x. Okay. Such that x is what? X belongs to some natural number. Why I chose this? Because if I write its natural number, definitely it's going to start from 1. Okay. And it should be stopped at 5. So I write over here lesser than equal to 5. So this is my first set builder form. Hope you got it. Next one is the same. It's a 4 part 5. 4 part 5, we see that 1, 4, 9. Then like that it continues. 16 and so on. So you have to understand what is the pattern of the numbers. They try to mean in this way. So basically we see what? These are the square of all the integers, positive integers or negative integers, whatever you can say. So you can write it in many ways. One of the ways will be, say, so can you see this, the blue ink? Just let me check whether you can see this. I'll try to write in a different ink, with a different ink. That is a black name. Okay. So these are the square of integers, as you can see. So what we do, we take x square such that, again I can write x is integer. So if integer 0 is also there, so better we write n. Okay. And n is stopped at where? N is stopped at 10, because it's 9, 16, 25, then that means it's 1 square, 2 square, 3 square up to 10 square. So what we do, we stop here x lesser than equal to at 10. So this is the answer for 4 part 5. So the next is 5 part 3. Here what we are doing, here we are writing the elements. That means we try to show up something like roster form. So what we do over here, it's some integer where x square is lesser than 4. So x square is lesser than 4 means x can be 0, because 0 square is 0. X can be 1, x can be 2. Can x be 3? No, because 2 is maximum and 2 square is 4. If x becomes 3 or more than 2, it becomes what? Its x square will be more than 4. As well as the negative integers you get. So here we can write these elements are -2, -1, 0, 1 and 2. Because you know, if you square this, you will get exactly up to equal to 4. Okay. Now 5 part 2 is something where we write out the elements. These are also integers. Please always take care of this, the conditions mainly. So it's from -half, it's lesser than equal to given, -half lesser than x lesser than 9 by 2. 9 by 2 means, this 9 by 2 means it's 4.5. So that means some integer which is lesser than 4.5. So that means it extends up till 4. Okay. It's more than -half means it starts from 0. So it will be something like 0, 1, 2, 3 and 4. So this is how we can convert simple set builder to roster and roster to set builder. Okay, we write few questions from exercise 1.2, you can see, and then same NCERT we have written. Now first we have to find out which sets are finite and infinite. So we have discussed many things about finite, infinite. So in compared to that, this is very easy. Set of months, you know, there are 12 months, those are countable, so this will be finite. Okay. Now this, here you can see the positive numbers or the natural numbers, it's positive integers. So it's going on and on. So obviously it's defined, but it's infinite set. So these are the kind of examples, sums you will get. Now let us see 5 part 2. 5 part 2 is a sum where we see there are two sets. A is what? It's X such that X is a letter in follow. So that means these are the elements or members. So if you write the simplified version of it, you get F, O, L and W. And here B is something like W, O, L, F, because Y such that Y is a letter in wolf. So what we get that these two sets are equal. So A is equal to B. So these are the equal sets. Why so? Because now although there are many letters over here, they are getting duplicated. So we exclude them and choose F, O, L and W. Number 6. Coming to number 6, we see that few sets are given A, B, C and D. We are trying to find out which sets are equal to each other, which sets are equivalent to each other. So what we find here, A 2, 4, 8, 12. So none of these are 2, 4, 8, 12. These are 4, 8, 12, 14. So what A and C, they are not equal. Okay. But what we can find that they have the same cardinality. So A is equivalent. A and C are equivalent sets. Okay. So the numbers of elements in A and C are exactly same. So it will be equivalent. Now this is also equivalent. These are also equivalent. Say you can say this is also equivalent to B, because B is also 1, 2, 3, 4, or equivalent to D also. So these are equivalent sets. But B and D, look at it. B and D are equal sets because they have the exactly same elements. So it is written in a different way, that means randomized only. So B will be equal to D. Let us proceed with exercise 1.3. So we get two sums over here. I have selected sum number 5 where A is 5. That means A is a null set. And we have to find out what is the cardinality of power set A, and we have to also write out the power set of A. So that means, first of all, just you see how many elements are there in A. How many elements are there in A? No elements. That means zero number of elements. Okay. So NPA, you always know, there is a formula behind, I told you that day, that is 2 to the power of this cardinality. That means here what we get, n of A, that means n of A is 0, because this is an empty set, null set. So this will be how much? 2 to the power 0, that is 1. NPA will be 1. Is it okay? Now, so if we try to write out the power set of this, the power set of this will look like look at it. That means, you know, that null set is a subset of every set. So it's a null and only one set is there. So power set of A, how many elements are there? Cardinality will be 1 and this is there. So you can also write like this. Okay. Because you know these are the subsets of A actually. Okay. So how many subsets are there? Only one subset is there. That is phi itself. Number 7. Write the intervals in set builder form. Write the intervals in set builder form. So here we got, it's an open close interval given 6 to 12 and a closed open interval given -23 and 5. So what we write? Here we write in the set builder form x such that nothing is given, nothing specified, so we will take the real numbers. X belongs to R and 6 lesser than x we will not put equal to, because since this is open, and lesser than equal to 12. So here we will put an equal to and this will look like this. X belongs to R, x such that x belongs to R, and this is the condition. Next it will be any other element you can take, y such that y belongs to R and it starts from 23, and here we see it's a close, so lesser than equal to y lesser than 5 because it is open. So these are the two particular sums on which there are many other sums you can proceed and do yourself. Again we have chosen few sums from exercise 1.4 and I see here sum number 2 where A is given AB, B is given ABC. They are asking, is A is a proper subset of B? Is A is a proper subset of B? So you can see A is really a proper subset of B. The answer will be yes. Okay, the answer is yes. Yes, AB is a proper subset of B. Now find A union B. A union B, that means all the elements to be considered. So it will be something like A, B, C. So this is the value of A union B. Okay. Look at number 11. Number 11 is R minus Q. What is R? R actually, R denotes the real set, real numbers, and Q denotes the rational number set. That means real minus rational. What is left behind? Irrational numbers. So there is a symbol, you can write T. Okay. So you can write T over here. T depicts that R minus. T is actually, T denotes it's an irrational number. It's an irrational number. Real minus rational will be irrational over here. Now coming to number 6. Number 6, you see that few sets are given A, B, C and D. We have to do two sums over here. I have chosen number 9 and number 6. Okay. So basically it depends on the operations which you have learned, the union and the intersection operations. So here what we get, A intersection B means you have to pick the common elements between A and B. So what we find, 3, 5, 7, 9, 11, B is this. So 7, 9, 11, these are the three common elements which we take into consideration for A intersection B. B union C will be the union of both these sets. So we can write, unite them. We can unite this. So 7, 9, 11, 13 and 15 we can write. So now again what we need to do, we need to take the intersection elements from these two sets, which we take as 7, 9 and 11. So this is the answer because 7, 9, 11 is common in both the sets. Let us see number 6 as well. A intersection B union C. A intersection B union C will be A, already it's written on the board, it's 3, 5, 7, 9, 11 and intersection B union C I have written over here. You can unite and get 7, 9, 11, 13 and 15. So again what we need to do, we need to find out the common elements between them. So I can easily find that 7, 9, 11 exist in both the things. So it will be 7, 9, 11 which are the common elements between these two sets. So this is the answer, this will be the answer, that 7, 9, 11. Okay, now we will see exercise 1.5 where we have selected few questions. It's 3, 7, 6, 7. So these are basically dependent on the complementary laws and the laws which we know through the set laws. A union A dash will be universal set. U dash means it's already a kind of null set. Null set intersection null set will be null set. Okay. We will look into it. This is number 6, a little tricky one. Let us see 3 part 6. X is a perfect square where x belongs to n. That means x is a natural number and perfect square, like say 1, 4, 9, 16, 25. These are the kind of numbers which are there in A. So find A dash means the numbers which are not perfect square. So what will be A dash? A dash you can write the complement they have asked you to write. So you can write x, okay, such that x is not a perfect square and obviously x belongs to n. So this will be the thing. Now look at number 6. Number 6 we get set of all triangles. Set of all triangles means all possible scalene triangles are there, right angle triangles are there, isosceles triangles are there, equilateral triangles are there, all possible triangles are there in U, that is the universal set. Now A denotes set of all triangles with at least one angle different from 60 degree. One angle different from 60 degree. That means, so one angle is not equal to 60 degree or many angles not equal to 60 degree. So you put in A all those triangles. Obviously this kind of triangles will be there. Say one angle is 60, one angle is 90, one angle is 30. So these type of angles are there in A because at least one angle is different from 60 degree. But two angles cannot be different from 60 degree. In that way also it is true. But what will be A dash then? A dash will be set of all equilateral triangles because the A dash will be set of all equilateral triangles in that particular plane. Because why so? Because you see here one angle or many angles are different from 60 degree, but if all angles are equal to 60 degree, that will not to be considered. So that is there, that will be in A dash.